Hello and welcome back to another video in the C# beginner series. Today, finally, we're going to be talking about methods. So, what is a method? A method is a group of statements that perform a particular task or a given task. So, throughout this series, we've been using a lot of built-in methods that are built into the C# language and the .NET framework. So for example, in pretty much all of the previous videos, I was using console.writeLine to print something out to the screen. Say, howdy partner, like that. So writeLine is a built-in method, so is readLine. I haven't had to create this, I just know that it exists and I know how to use it. It was created by someone at Microsoft or whoever wrote the writeLine method. But it's built into the language, so we always have access to it whenever we need it. But we can also define our own methods. But before we do so, just want to quickly talk about the difference between functions and methods. So you might hear some people call the writeLine method a function, or they might call a function a method, or vice versa. So what's the difference between the two? So it's not super important that you know the difference, but it's something to be aware of as you go through your programming career. But they're essentially the same thing. So they're a grouping of statements that are to be executed. But the difference is that a method belongs to a class and a function can stand alone. So in object-oriented programming languages like C#, which is what we're working with, or Java is another example, it's nearly always going to be a method that we're working with because we're always working inside of classes. So for example, in here, we're in the program class, and then main is a method of the program class. We're going to talk about classes in the next video, so don't worry about it for now, but just so you're aware of the difference. And I've met people that have been in programming for 10 years and they still call functions methods or methods functions. So it's not going to affect you too much in the real world, but just so you're aware of it. But what are the advantages of writing our own methods? Why don't we just write everything lines of statements and let the program go do its thing? Well, the advantages are the code is reusable. So if I've written one method that does, let's say it squares some numbers for me, I can then go and use that method wherever I want. So wherever I need to square a number, I can then use that square method wherever I like throughout the program. I don't have to write out the same statements over and over again. I can just call my method and it'll do the job for me. It's easier to test with methods as well. You can just test certain methods or certain blocks of methods, and then if something fails, it's easy to modify just the method and it doesn't affect the whole program as a whole. Also, if we have one method, it can accept many different inputs, which you're going to see in a second. So let's create some of our own methods. So as I said a second ago, main is actually a method. So it's a method of the program class. And when we're working in a console application like this, main is a bit special method, so it gets called automatically when the program starts. So the very first line of code that will be run in the console application is the first line that's inside the main method. There's other things that happen behind the scenes, but you can think of this as your starting point, essentially. So what we've done in the previous videos is we've actually been working inside of a method and we've been writing statements for that method. But we're going to create our own one now and you'll see how it works. So to create our own method and then use it, we have to first declare the method and then we call it by using its name and that will run the method for us. So let's start out with a simple one. We'll do square this. Okay, so what have I done here? I'll put the data type in there. Cool. So don't worry about static keyword at the moment. We have to have that because we're in a console application and the main method is static. We'll talk about that later. You can just forget that for now. So when we declare a method, we have to first specify a return type. So if we want this method to return a value, we have to tell the program what type of data are we going to return from this function. So that goes before the name of the method. And then you have the name of it. So in this case, it's square. And then you have your parentheses, and then any optional parameters that you want to define as well. Following that, we then have a couple of brackets, and then any statements we put inside of the brackets are then a part of the square method. Okay, so this is the return type. We're going to return an integer. This is the method's name, and this is the parameter that we're going to pass to it when we call the method. All right, and then we need some statements in here. So we need some work for our method to do. I'll create a variable called result. I'll say that gets x times by x. And I want to return that result. Okay. So I've created a variable called result. And then whatever I pass in as this x parameter, that value is going to be placed in these two x's here, so these two variables here, and that will get passed to the result, and then I'll return the result. So remember, parameters are optional, we don't have to have those, but I'm going to show you a method that doesn't have them and that doesn't return anything. But in this case, I'm wanting to return whatever has been squared, so whatever is passed into here. Now when I want to call the method, so I've declared it, I've created it, but now I want to call it from somewhere else. So up here we'll say int result or squared number. I'm creating another variable called squared number, and then that will get the value that is returned from my squared function, squared method. See, even I do it myself. And I'm passing the number 5 into the squared method. So this number will be passed into here when the method is called. It'll go 5 times 5, return that into a result, and then the result will be returned and passed into my squared number. And then I'll print that out to the screen so we can see the result. Come on. That one. Okay, and then I'm going to print out that result there. Okay, I'm going to use something called a breakpoint here, so you guys can see how the program moves around and where it jumps around to. So just by putting my cursor over in this column here, you can place what's called a breakpoint. When the program is running through and it hits a breakpoint, it'll pause the program, and we can then just step through it line by line and see exactly what it's doing. So it's a really good way to debug through your programs, and you can see exactly what it does each line of code. So super important skill to learn how to use these breakpoints properly. So if I run this, so as I said before, main is a special method when we're working in a console application. This method runs automatically. So this is actually the first line of code that will get run. And I'm saying pause on that line. So you're going to see the very start of the process. So I'll press run, and you can see it's paused operation. So it's telling me, yep, we're at this line here. What do you want to do from here? These buttons at the top here control how we can step through the program. So step into will step into any methods that we're running. So the square method, we can step into it and see what's happening inside of that method, or we can step over and just move to the next line in the current scope. In this case, I want to step into the square method so I can see exactly what's happening. If you hover over your variables, you can see it's got the value of 0 currently. So nothing's happened to this variable yet, but you'll see as I step into it, you'll see what happens. So I'm going to say step into. The program jumps down here. It's now running my square method. You can see if I hover over x, so the argument was passed to the parameter here, and the parameter now has the value of 5 because I passed it here. Do a step again, or step in here. Nothing happens until you've actually stepped to the next step, so that's why that says 0. So if I step again, you'll see what's happened. So result now has 25. That's because 5 times 5, 25. And then the next step is return that result. So when this line runs, the result will be returned and passed into the squared number variable. So step over, goes to the end of the bracket, step over, comes back up here. And as I said, it doesn't show anything until you've moved to the next line. So step, and you can see that squared number now has 25. Next line in the process is we're going to write that value to the console. So you've seen this lots of times in the previous videos. So just step over and step over again. That's our read line, which holds the console window open for us. And there we can see printed out the number 25. So we don't actually need to store this in another variable if we don't want to. I can actually just print out the function, the return of the function straight away. So if I get rid of this and this, I just want to say write line whatever is returned from the square method. So in this case, the return value, which is result, is being passed directly into the write line. See, write line has its own parameter, which is just int value. So this returns an integer, which we know is 25, and write line can just print that out for us directly. So this will have the same result. I just wanted to pass it into that variable at first so you could see what it was doing. But see there, just prints out 25. Okay, so what if I had a method that didn't need to return any values? Well, in that case, we can use a keyword called void. Now, void means this means nothing. So it's this method's return type is void. So it's not going to. We don't need to return anything. Say hello, like that. I'm also not going to have any parameters at this point as well. So you would use void methods in the case where you just need the program to do something. Essentially, like you don't have to pass it any data, you don't have to send back any results or any data. You just want it to do a thing, whatever you want it to do. You'll see what we can do with it. So I'm just going to say inside of my say hello method, I'll say hello, good sir, like that. And then if I come up here, I don't need the console write line method up here anymore because I'm doing it inside of the say hello method. I can just say hello, 2 brackets like that, no parameter because I haven't defined anything. This is hello, good sir. Hopefully that's nice and clear. I could run methods as many times as I want to, so I can say hello, say hello. I'll do it 3 times like that. Hello, good sir. And we can also alter methods as we go. So let's say I wanted this to do what I've done here, and I want this to say hello 3 times. What I would do is copy and paste that. I will delete 2 additional methods here. And it's good practice in programming to rename your methods and your variables as you go so that they reflect what you're actually doing. So this is now actually say hello 3 times. And be nice and descriptive with the names of your function, names of your, see, I did it again, names of your methods and your variables. That way when someone else has to read your program, they'll know what's going on. So if I was another programmer, I didn't write this program, but I came in here and I went, oh, there's a say hello 3 times method. I wonder what that does. Hopefully it will say hello 3 times. And there we go, say hello 3 times. Nice little shortcut as well. If you need to rename a method, you can right click and rename. And you can see it renames it wherever it is in the program. So you can do that nice and safely, and it will rename as we go. But let's change this again. Let's say I want to say hello to someone, so someone's name. So I might want to add a parameter into this function, method. Say hello to, apply. I'll get rid of these lines. Say hello plus, we need a parameter here, so string name. Say hello to name, like that, right? And then when I call that method, now that it has a parameter, you'll get a little error saying there is no argument given that corresponds to the required formal parameter name. So saying in order to call this method, you have to give us a parameter. I'll just say David. Okay, and now Visual Studio is all happy, and you'll see what will happen here. Hello, David. So the method was called, the argument David was passed into the method, and then we console write line hello plus the argument, which is David. So you can see here as well that the square method is doing nothing at the moment. It actually says if you hover over it, program.square is unused. So this doesn't just run on its own, it has to be called somewhere in our program for that method to run. So whilst I've done all this work with the say hello method, the square one's just been sitting there waiting to be called. And if I wanted to call both, I could do so. So I could write line and don't need a string, just say square 25. And you can see it actually colors it in a bit, and that message has gone away now. So now both my methods are going to run as I run through this. Hello David, and the number 625. Cool. So you can see how flexible methods and functions can become. We can adjust them as we go. Easy to test with them. We can call them from anywhere in the program. We only have to write out these statements one time, and then we can just call the method whenever we want to. Best practice is to keep the method as small as you can, and only have it doing one task. So I wouldn't want to have a method that's say hello to and square a number. That's just confusing. Split that out into 2 methods. Okay, so it's best practice to keep them as small as we can. All right, in the next video, we're going to talk about classes. So that's what we've been working with so far. We're inside of the program class, and these are methods of the program class. So we'll talk about that in detail in the next video. Thank you for watching.